Forces. What does the force cause you to have the power to do?
It allows you to move things with your mind.
Very good. This is they chose a very apt term in Star Wars for the force. Because what the force allows them to do is move things. Okay? It's called telekinesis. Somebody asked if I believe in it. That's up to you to figure out. Okay, so what does a force have the power to do? It has the power to cause a resting object to move or to cause a moving object to change speed or direction. So it has the ability to cause a moving object to do what? What is the term for that?
Change of velocity.
Good. And so what is a change in velocity? What is your rate of change of velocity, George?
Acceleration.
Excellent. Awesome. Okay. So if you make something that is standing still, what is something that's standing still? What is its velocity? 0. Okay. And if you make it move, is that a change in velocity? Yes. So both of these are acceleration, right? That's why I needed you to know what acceleration is. Because forces are critical in earth science. A lot of what we talk about in earth science, in fact, everything that has anything to do with physics that we talk about in earth science, has to do with forces. Okay? Astronomy in particular, there's a lot of information that we'll need about forces, but even in regular old study of rocks and kinds of rocks and whatnot, forces are what make rocks do the things that they do on the surface of the planet. That's what makes earthquakes act the way they do, and volcanoes and things like that. Yes, Jacob?
What do rocks do on the natural surface?
Sit.
Other than, like, nothing.
Well, there's lots of stuff that rocks do. One thing that they can do is turn from one kind of a rock to another kind. One of the things that they can do is be displaced by something like an earthquake or volcano. One of the things that they can do is be subducted under another layer of rock, and there are lots of forces involved in that. So there's a lot of movement. Our planet looks static and seems static to us, but it's really not. It's very, very fluid. Yeah.
How does one rock change to a different type?
It's an excellent question. It has to do with a lot of temperature and a lot of pressure. And so when we get into rock types, which will be pretty soon, I'll definitely explain that. Yes, Aaron? Okay, so let's move on. Let me describe the SI units for force. Okay, it's called a Newton. Newton is a very, very, very famous physicist, and it's named for him. It's also named, Fig Newtons are also named for him. Not really.
If he invented it.
But no, he didn't. But so the Newton is the unit of force. That doesn't really tell you much, right? What's a Newton?
It's a really, really good snack.
It's a really yummy snack. I
He's a very smart person.
totally agree with
And
you.
a really good snack.
Okay, so the units we have here, what do these units imply? So we've got, what is this a unit of?
Measurement.
Weight, mass,
Mass, good. What's this a unit of?
okay, length,
Length. Okay, what's this a unit of without the square?
Time.
Time, very good. So, a Newton, 1 Newton, is the force required to cause a 1 kilogram mass to accelerate at a rate of 1 meter per second squared. So meters per second squared is the unit of acceleration. Kilogram is our SI unit for mass, right? So those combined equal force. It's very important that you know that mass is part of our unit for force, because mass is critical in determining the force. Think about it in terms of football. If you weigh 80 pounds and you're running and you run into someone who weighs 300 pounds, are you likely to get injured?
It depends on how hard you hit them.
Are they likely to get injured?
Depends on how hard you hit them.
Yeah. Depends on where you.
Or right,
Yeah.
right. But say you're just running like straight up and down running. Not that we do that in football, right? But you're just running along. Okay, or let's take football out of the equation. Let's just say we're having a foot race, but this is a special kind of foot race.
We hit each other.
And you each have a different starting line, and you run as fast as you can and run into each other in the middle.
The person who weighs more. We just get all carried balls.
Right, the person who weighs more probably won't get hurt. The person who weighs less probably will. That is because the person who weighs more exerts more force on the other person. Okay? Does that make sense? Yeah?